In this video, we're going to learn about coordinate covalent bonds. So let's start by drawing a Lewis structure for Bf3. Boron has 3 valence electrons, and fluorine has 7. So the fluorines all want to form one bond to get to their octet. But in the previous video, we looked at how elements will form as many bonds as they need electrons. It's a little bit tricky with boron because boron needs 5 to get up to the octet, but it can't form 5 bonds in the sense that it only has 3 that it can use for sharing. So boron is in a little bit of a dilemma here. Note that you can form Bf3, no problem, but the boron does not have its octet. And this is a stable structure, although it is a substance that will react with anything that can provide extra electrons. And this is where we get to the concept of coordinate covalent bonding. Because if I'm making not Bf3, but actually Bf4 minus, what I can do is I can say, all right, here's an F, and it's got 7 valence electrons. But actually, since Bf4 minus has an extra electron, that's why it's negative, let's just put this extra electron on the F and make it an F minus, which is a pretty stable ion. F is very electronegative after all. And what I can do, actually, I'm going to designate this as an X here. So we've got a dot that means an electron, and then an X that means, oh, that's the extra electron. So anyway, I circle these two, and what we're going to do is have both of these electrons go to form that bond to the boron. So that's called a coordinate covalent bond, and that just means that instead of it being that boron and fluorine each put 1 electron towards the bond, it just means that both bonding electrons came from the same source. And this results in the Lewis structure, where the fluorines all have their 3 lone pairs. Yes, this particular fluorine started with 4 lone pairs, but if it used both electrons to form a bond, that's not a lone pair or even a non-bonding electron. That's just both electrons going to form a bond. So we end up with this. Now, of course, if you count up all the electrons, there is an extra electron, and we accounted for that before. So what we do is we put brackets around the whole thing and put a negative to indicate that it's a negatively charged ion. This also goes for positive ions. So for example, NH4 plus. Here's our N. We have 4 H's. And what I'm going to do is show bonding. Now this is NH4 plus, so actually there should be an electron missing. And what I'm going to do is I'm going to take that electron away from this hydrogen. So instead of it having 1, it doesn't have any, which is fine. Because what we can do is we can take these 2 electrons from the nitrogen and go here to form the coordinate covalent bond. And we end up with a Lewis structure that looks like this. And of course, brackets around it and the positive charge. Now, could you get to this Lewis structure without using a coordinate covalent bond? Absolutely. You could, and there's nothing wrong with that. The way that you would do that is instead of taking the electron away from this hydrogen, you take it away from the nitrogen. And that way, the hydrogen has an electron, the nitrogen has an electron here, not 2, and then they come together and form a bond. I will note that when you're looking at this structure, all 4 bonds are identical, and that's supposed to be the way it is. It's not that you have 3 bonds that look like one thing and then a 4th bond that looks different. These bonds are all supposed to be equivalent. So ultimately, the structure that you get, whether you use the coordinate covalent bond or not, you'll still get to the same place. But it is important to note that this is another perspective that you can use on bonding. I'm also going to show this out with the nitrate anion, NO3 minus. So we have 1, 2, 3, 4, 5. Sorry, 5. I miscounted on my nitrogen. I was thinking about oxygen. 1, 2, 3, 4, 5. And here comes our oxygen. 1, 2, 3, 4, 5, 6. And I'm actually going to make this oxygen, which is very electronegative, the one that has the extra electron, which I'm showing with that X. That electron is an electron just like any other electron, so there's no problem in showing it as an X. It doesn't change anything. This is strictly so that you can see it. Okay, so we have 6 electrons around this oxygen, and we're also going to put 6 electrons around another oxygen. 1, 2, 3, 4, 5, and I'm actually going to put the 6th here. So let's form some bonds. We're going to take the N and the O, and this oxygen being already negative or having the extra electron, it's acting a lot like a halogen, so it really should be getting one bond. And you can see it only needs the one. It's got 2, 4, 6 from the non-bonding electrons. Add a bond, we're at the octet, and everything's good. Now let's go to this oxygen, and we can form one bond. And we know that oxygen needs 2 more electrons, so it needs 2 bonds. So we get to this point where we've formed a double bond between the N and the O. This is where it's a little bit tricky, because as it stands, well, this oxygen's happy, it's got its octet. This oxygen's happy, it has its octet. And actually the nitrogen's good because it has the 3 bonds plus the lone pair gives it its octet. Now, this oxygen is missing 2 electrons. And so what I'm going to do is I'm actually going to take this electron here, and I'm going to pair it over here. So notice how we've got 2, 4, 6, and then it's kind of like there are electrons missing over here. Well, that's where the nitrogen comes in and forms a coordinate covalent bond, and we get to this structure right here, where there's an N singly bonded to the O, doubly bonded to another O, and singly bonded to this O. So this O got the coordinate covalent bond. It's got 1, 2, 3, 4, 5, 6 from the lone pairs. This O has 1, 2, 3, 4 from the lone pairs, plus 4 bonding electrons. And then this one over here, it has 1, 2, 3, 4, 5, 6. 2, 4, 6 plus the bond gives us the octet. Now this whole thing overall, sorry, I kind of went through those electrons. This whole thing overall is -1. And that would be my Lewis structure for the nitrate anion. So I hope this video has been helpful. Please feel free to leave any questions or comments in the comments section below. Thanks.